So the Convex naming system is the system that we use in Convex to give meaningful names to digital assets and to autonomous actors and smart contracts and all of the different entities that we want to use in the Convex ecosystem. So it's a fundamental bit of infrastructure that makes it possible to interact with all the different entities that can exist within the decentralized open economic systems. So it's a very important thing to understand, and it's got a few similarities. So for people who are familiar with the internet, and we see like www.google.com, which is the domain name system, which was a system that's operated globally to manage internet domain names. It's very similar to that. There's this concept that you can have names of different addresses or entities that exist in the internet. You give them a name. It's exactly the same as that in Convex. We want to be able to give a good meaningful name to all of these different components. But of course, we can't use DNS directly because Convex is a decentralized network. It's got some different properties. Most importantly, it has to be decentralized. We need this system to operate on a global decentralized basis, and it has to operate fully on chain in the sense that it's running within the Convex virtual machine. That gives us some technical challenges in making that work, but it also gives us some advantages because it does mean that the name system can be built in a way that is free from centralized control. So you've got centralized control over DNS names, for example, whereas a Convex name system is a truly decentralized system. If you're familiar with the crypto space, you may also have noticed .eth, .eth names that some people use, and there's a few other similar kinds of decentralized naming systems, which are sort of similar in concept to some of the ideas that Convex uses. There are, however, a few things that are quite unique to the Convex name system. So as I go through, I'll try and point out some of the sort of key ideas and some of the things you can do with the Convex name system that maybe aren't possible with some of the other naming systems that are out there. I am keeping an eye on chat. So if anyone has any questions or wanting to, drop any comments in, then please do comment. Please do ask any questions as we go through. I've also got a few questions come from the on our Discord, so I'll try and make sure that we answer all of these as we sort of go through the conversation. So. Just a couple of thoughts on, why do we need a name system anyway, or why do we have these name systems in the first place? A few reasons. I think one of the most important things is it's much easier for humans to interact with. So where you have IP addresses on the internet, like 10.1.1.196, or whether you have crypto addresses, so wallet addresses, or in Convex accounts are numbered, so you've got some long account number that you might want to refer to. They're not very human readable. They're easy for people to make errors. So you want to find a way that we can give people names that are human readable, that are understandable, and less error prone. And that helps us to find things and to understand the things we're interacting with. I think another key point is it actually gives a layer of indirection and flexibility. So, for example, if you've got a name in the Convex name system, and you've given a name to a library, a software library that you want to use, and over some time you may produce a new version of the library and create an update and deploy a new version, and the new version that you deploy might be at a different address, but you still want to use the same name, and you can do that. In fact, you've got a name, you just can change the name to point to the new address and continue as before. working with the latest version, but not having to change the name, not having to change any of your code. So it gives that extra layer of flexibility if you need to change the underlying details about some entity or something that you want to interact with. And that is very important because you don't want names to change for your users. Yeah, if the name changes and users have to update their address book or update all of their records or update their databases, it's going to be very, very painful, and you're going to get broken links everywhere. So as much as possible, you want the names to be consistent, but the metadata, the information behind that name, you might want to be able to change. So the name system gives you that extra little bit of flexibility in helping to manage that kind of layer. And yeah, from chat saying, yeah, like an abstraction layer. That's exactly it. It's giving you a layer of abstraction so that you can manage a bunch of different information related to a name without the name itself changing. So as a user of the name, you only need to remember the name. And the person who's managing or owns that name can update all the information as and when things go on. Another very important thing about a name system is it's not just a name of a thing, but it also lets you maybe attach metadata that's important. So, for example, in the DNS, a lot of security tokens and keys and these kind of things get put in the DNS records, which are very important for things like email security or website security. So the ability to attach metadata is very important in a name system. And again, the metadata might change. Yeah, you might update some security keys, you might update some of this information, but you don't want to change the name itself. So metadata, key part of the system. And finally, you want a consistent standard so that you can manage it in a convenient way. So obviously in DNS on the internet, you have domain name registrars. There's a big process about managing domain names, but it enables you to manage names in an efficient way and at scale, and even have whole businesses operating around managing names in different ways and making sure that those are managed properly and that they're trusted, etc., etc. Exactly the same for the Convex name system. Yeah, we need a standard here so that the management and the interaction with names can be done in a consistent way. The twist is, I think, on Convex is that because it is decentralized, it is up to the owner of a name to decide how that name can be controlled. So if you have a name and you say, okay, well, I would like that name to be controlled by a smart contract and have some governance rules such that only if a particular DAO votes to change the metadata, only then does the metadata get changed, then you could enforce that rule. Yeah, you could encode that rule in a smart contract or in an actor that controls the metadata. And that's super important because it means that you can create names that can be trusted on a decentralized basis and that can be managed by decentralized actors or smart contracts or these kind of things. So you can really tighten down the rules of how the different names will behave. And the Convex name system is designed to be super flexible, so any name can have its own different set of control rules if you want to. So you've got this almost unlimited flexibility to build parts of the name system as to suit your particular needs. Another question from chat. Can you change any wallet that would be under it? So let's say you were using a name to point to your wallet or your account. Yeah, and let's say your account was originally 457. But then you decided you wanted to point it to a new wallet that you've got, which is 1003 or something, then you could, yes, update it so that the name would point to your new account. So if you were using a CNS name to receive payments, for example, and you wanted to change the account to which those payments went into, you could change the mapping for that name so that it now points to a different address. So yes, that's the kind of thing that you might want to change using the flexibility to change the details behind the name. So obviously that's all done with security controls. Yeah, so you can only do that if you're actually the owner or controller of that name. But good question, great question. So we had convex names have gone through a little bit of an evolution. We started with quite a basic naming system. We originally started with no naming system. You had to refer everything directly by an address. Yeah, and that worked. It means you can do everything you want, but it's not very convenient, and it's a little bit painful. And we knew we wanted a name system at some point, so we created the first version of the convex naming system. Was a sort of a flat naming system where everything exists at the same level in the naming hierarchy. So there's really no distinction between top level domains and intermediate domains. It's all effectively one level. Now the new revamp of the naming system is a hierarchical naming system, which means that you've got like the top level domains, and then you've got subdomains that are completely separate, and they can be managed differently. They can have different rules. They can have different access controls, etc., etc. And in fact, they can have children as well, and those can have children. And in fact, it can go pretty deep. How many levels you want in your domains if you really need them. So it's now almost infinitely flexible, and it's fully hierarchical, so that you can set the governance rules for whole sections of the domain tree as you wish. So I'll do a little bit of a quick demo just to show you what we can do with the Convex name system, and then I'll get on to sort of talking about some of the the future plans and some of the other ideas around this. So let me just switch over to I've got a little Convex network running here. I'm just going to open up a REPL. Which is going to be accessing one of the accounts I've got on the network. This account, let me just check. I think it's account number 12. Yes, that's right. So the address of this account is account number 12. So as usual, it's a Convex REPL. Anything I type in the bottom area gets executed, and we see the results appearing up in this top area here. Typical way we do interactive development when we're in sort of development mode on Convex. So first of all, I just want to highlight one of the most common things that we do with the Convex naming system, which if you've followed any of these talks, you'll have seen before, is whenever we import some code, some library code. So I'm going to do an import. And I'm going to import convex.asset, which is one of our core libraries, and I'm going to give it the asset name. What that is actually doing is it's actually using the Convex name system to look up this convex.asset name and to say, okay, where is this particular library located, and how do I get its address? So if I execute that instruction, you'll see it's come back with the address 20. So the address 20 is actually the library which implements convex.asset at the moment. And that is, of course, the totally normal developer usage. I've created an alias. So now in this account, the word asset is referring to the account 20. So I can just refer to this directly as I want to work with different assets. This is an example of a library. If at some point we ever wanted to change the address of the convex.asset library, we could create a new version and point convex.asset to the updated version. Now there obviously are security things around when you'd want to do that and how you'd want to manage that, but it is possible, and it is definitely a feasible use case. Note that people who have already done this and already imported would have set asset to point to account number 20, and they'd be using account number 20, and that's not necessarily going to change unless they want to update it. Yeah, so it doesn't force people to automatically use the new library. It's just new people who come in will get the new version of convex.asset. So question from chat. Does this mean that asset.server.sector.user.amazon.cvx would be possible to create? Yeah, we'll do that. We'll do that. That's absolutely possible. So um, let me just finish this quick demo of the basics, and then I'll come back to that because we can definitely do that one. Um, so that's a library, but it also works for assets themselves. Yeah, so I can do import currency.usd. Let's just call it USD. And currency.usd is recurring to account number 39. But this isn't a library. This is actually a digital asset. It's a token. So I can do asset. What's my balance? What's my balance of USD? And I've got 0 USD at the present time. But that again shows the flexibility of the name system. You can refer to assets, you can refer to libraries, you can refer to code, you can refer to your own user wallet account. So CNS is pretty general in that sense. So how do you actually interact with CNS? Well, CNS is actually integrated in a special. The root of the CNS is in this special account called the registry, which is actually account number 9 on this version of the network. And this is a special symbol, so this is going to be available to anyone who wants to look at it anywhere on Convex. Just for convenience, I'm just going to define CNS the symbol CNS just to point to the registry, just to save a little bit of typing. You don't have to do this, but it's just convenient. So I'm referring to the CNS here. So the simplest thing I can do is if I just want to create a CNS record, I can do CNS create, and then I need to provide a symbol. So I can do user.mic. Now, because of the security I've got set up on this system, the user namespace lets you generate whatever usernames you want. So I can do CNS create user.mic, and it's now created a CNS record. And just to check that that's worked, I can do CNS read, and again, user.mic. And you can see that there's this little record. This record has 3 entries, 2 of which are nil, and 1 of which is the address 12. So what are these 3 entries? This is the core of how CNS works. The first entry is the thing that the CNS record is pointing to. Currently, it's not pointing to anything, it just exists. The second element in this record is the controller of the CNS record. That's who has the right to update this CNS record. Now, in this case, it's 12, which happens to be me because I created this CNS record in the first place. And the third one is metadata. So that is the metadata attached to this CNS record, also currently nil. I've not actually attached any metadata to it. So I've got this record, but there's nothing. It's not actually really very useful at the moment. There's no data in it. So I can do, if I want to add some data or change some data, I can do CNS update. And again, I want to do user.mic, and I can give it. I can point it to an address. Maybe that's my wallet address, 666 or something. Who do I want to be the controller? Well, I'd still like myself to be the controller, so I'm going to keep myself as the controller, but I'm also going to attach some metadata. So what shall I have? I'll have just some random data. The metadata is any convex data that you want to include. So it could be that includes anything that's in JSON. It includes strings, maps, whatever keys and values you want. So that's just you know, a map with some a vector and some numbers inside it. So if I execute that, that appears to have succeeded. So if I do the read, CNS read again, you'll see that it's now filled in the data that I've executed with the update. So this is like if you're doing some back office stuff and you wanted to create and update your records, then this is how you could do it. Yeah, you just using code like this. Obviously, as usual, you can build a user interface to do any of this so that the user doesn't have to do this directly if they don't want to. Let's want to create some very hierarchical big name. So like, you know, asset server sector user Amazon CVX. Let's do it. Uh, that actually might be a good test because I've never actually created a name that deeply nested before. But that's good. That's a good test case. So it's going to have to start with user because user is the account, is this subdomain that we've set up that I've got access to create records in. But to be able to do server dot sector user again dot Amazon, capitals should be fine, and dot CVX. Yep, that's worked. So that's again, that's a deeply nested CNS name, and I should be able to read that. I'm just going to copy and paste this long string. CNS read, and again, I've got like this empty record that's associated with that long username. So again, I can update it. I can manage it. I can do what I want with it. So another question from chat. Can that metadata point to a smart contract? It absolutely can. So let's say this metadata we've just created. So I'm just gonna copy. So CNS update, that long username. If I put in 567 or something, that could be a smart contract. In fact, it could be a scoped smart contract. Yeah. So if I've got like a vector, it can have a keyword. It can be one of these scoped actors. So it can be a smart contract that's managed by actor 567, but has a particular key. So you can refer to a particular instance of a smart contract. Again, I probably want to keep myself as the controller. And again, I can put some, you know, name by contract, put in whatever metadata you like. And again, that's updated the CNS record. I can just read it. That's all been incorporated into the CNS record. So super flexible. You can really do whatever you like with these in terms of putting the right kind of data inside. Then the oh yes, if I want to create a CNS record for another user, so I can do CNS create user dot, let's say user dot bob, and let's say they have account 1000. So this is going to refer to their account. So that's good. That's worked. So there's now a user.bob CNS entry. But I want Bob to control his own CNS record. I don't want to manage it. It's up to him to look after this record now. So I can do CNS uh, control, and I'm going to make him the controller of his own account. So if his own account is 1000, I'm just going to execute that. So he is now the controller of user.bob. And notice if we try and take it back, so if we try and transfer the control back, we're going to get an error. Yeah. So it's a trust error, which is what you always get when something goes wrong. That means that you didn't have some authorization to do what you want, and the report is no permission to update CNS record. So because I transferred it to Bob, and the control of that record has gone to Bob, I have no control over it anymore. So this is really important because it means that CNS records can be managed like digital assets. You can transfer them to other people. You can transfer the control and you can transfer the ownership. Or you could have the ownership managed by a smart contract. Yeah. So you could have an actor that is responsible for auctioning CNS names, and as it runs the auction, as it gets paid in tokens or whatever currency it's auctioning the names in, then it can distribute those names to whoever wins the auctions. So all of this is possible because we have this ability to transfer and change the control of a CNS record on the fly like this. And notice that this is all on chain in Convex. There's no external tools. This is all happening on the smart contract on the virtual machine. It's all happening within transactions, so you can roll back. You've got all the transactional security guarantees. You've got all the digital signature checks, etc., etc. So the security of this is absolutely, top notch. This is the highest level of crypto security on every single one of these CNS interactions. There's no way that I can get that CNS record back from Bob now, no matter what I do, because I don't have the access rights to sign a transaction on his behalf. So question from chat. So you can sell a CNS record then? Absolutely. So you can sell a CNS entry record, or you could sell entire CNS domains. So you could control an entire domain and then allocate subdomains as you wish, but then you could sell the ownership of the entire domain to someone else. I would add the caveat that if you have a domain that's controlled by a smart contract, whether or not you could sell that domain would depend on the rules of that smart contract, because it might be that it's fixed and it's going to permanently stay under that domain or under those rules. So it is possible to limit your ability to transfer a domain. Yeah, which is important. Yeah, because if you're running on a decentralized system and you want to know that no one's ever going to take something, pull a rug out from underneath you and collapse your namespace, you want to know that all the way back up to the root there's strong security guarantees in place. So that's the model. You can create different levels of security and assurance and governance rules for different domains as and where they need it. So can you create a service under a smart contract and then rent it to anyone that needs that service? Yes. So that is certainly possible. You could have a payment smart contract. You could give it a CNS name. You could have subscribers paying a rent to the smart contract, and that service could include renting out a CNS name temporarily. Yeah. So I could see a name like service dot magic service dot so something like that. Yeah, you could have a name that's a bit like this, and the magic service can be allocating usernames which get rented out. And it could be user chooses the name. It depends on exactly what the model is. But it's very flexible. You can have that as a smart contract, and then you can have it taking rental, and then you can have it removing the domain, the CNS name if the rental isn't paid, for example. So you're checking the existence of a valid contract to maintain the names. So all of these things are possible with the CNS. It's basically between every dot, each one of these levels can define whatever rules it wants. If you think about it that way, that's a good mental model to think about how the CNS works. So that's a fully hierarchical sort of governance rules. What else? What else to say about CNS? For those of you who watched the video on trust monitors, um, it integrates perfectly with the trust monitor system. So if you've developed a trust monitor for your DAO, which is authorizing users to act on behalf of a DAO, for example, then you could use that trust monitor to control CNS names. So this is part of the part of what we're trying to achieve with Convex, of making things very simple and pluggable, means that all of these things work together nicely, and you can pick and choose which components you need to solve your particular situation. So I can create a smart contract. I can give it a CNS name, and I can set up a trust monitor that governs certain actions within that smart contract. Another question from chat: will Convex be setting up an auction process for names? Um, Actually, we probably will be finding, we need to find a way to distribute names. To be honest, we haven't finalized it. It's quite likely we will at some point have a public access auction for names. Um, but it's still open to some sort of good ideas and how we think is the best way of um, allocating names. So yeah, open to ideas. Actually, that's something where if someone's got really great ideas about how we should manage some of the name issuing, then that's definitely a chat to have on the Discord, and we can talk about some different ideas. So I'll just say some of the ideas I quite like having a sort of user space for names, and then anyone who is a community member can ask for a name, and we'll just allocate those names to people who are sort of known community members. So that's a good way, particularly contributors, people who've been early members of the community or bought Convex coins can basically get a sort of a username like this. Um, Maybe we have like an app namespace, yeah. So if you create an app, uh, and it's a legit app and it's a real project, you can have whatever name you want, yeah, to represent that app, as long as you're the first person to come along and develop an app. Yeah, we might have a something like CVX dot blah, kind of like the eth1, that if you want to use for public names, now those we probably would auction, yeah, or do something like that, or have some system where we allocate them based on what's the demand, because those are more like status, sort of public name kind of things. So but all of this is open to discussion, and we will issue a bunch of names on protonet, but because this is an infinitely large namespace, we can have different rules for allocating different parts of the namespace. Yeah, and that's what I think is really important, is thinking imaginatively about how we can use this very flexible system to allocate different names in appropriate ways for different use cases. Um, we can even, I mean, we can even potentially have names that are sort of dynamically generated. So, uh, we can have something like dynamic name, and then whatever you put in as a dynamic name, it looks up through a smart contract and tries to work out if that name's currently allocated and who's it's allocated to, and it can do arbitrary logic, potentially, to um, assign, return a CNS record for that name. So in that sense, you could actually have an infinite number of names without even having to pre-allocate them. It sort of generates them on the fly, or it looks up information on the fly when that happens. There's some complexity around this, but it is possible. The complexity comes from the fact that CNS lookups are meant to be read only. Yeah, so you could compute an answer through a read only query, but if you wanted to actually change state and like generate something and record something, you can't do that within a query because the query is read only. You can't update the state. So you'd have to design this. You'd have to either design a different interface that doesn't use a query, yeah, so so it can update the state, or you'd have to find some way of being able to answer within the scope of a query without messing up your process. So there's some technical complexities around that, but yeah, you can do these sort of dynamic lookups and sort of create these names on the fly. So more questions. Similar to DNS, it can check availability. Yes, yes. So I mean, if I try and CNS look up something which doesn't exist, it's just going to return nil. Yeah. Uh, Nil. Yeah. So there's nothing there. So it does it every CNS query in a sense is checking availability. Um, Now, if it's not available, you can try and acquire it, um, either because you already have the rights, or you talk to a smart contract that can give you those rights. Um, Acquiring different names under different systems might have a different interaction model. So if a domain was allocating names on the basis of an auction, you'd presumably have to bid in that auction and win the auction before you'd get assigned the names. So there might be different mechanisms for determining availability and participation, and how you actually access those names. It's a bit hard to sort of predefine what all those interactions might be, but yeah, it's similar. It is similar to DNS in that sense. It does let you query. What is the difference looking at the whole global state versus local use? So all of these are global. All of these are names that are visible in the global state, and so it's effectively there's in that sense there's no difference. Yeah, all of these names will be global on the convex network, and everyone can see them by doing CNS queries. And this is important because the whole point of a name system is that people can agree what the name points to. It wouldn't make much sense everyone using different names and have different name mappings and different metadata, because they just get very 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 confused. Having said that, if you are running a development version of Convex locally, for example, you can hack CNS to do what you want. Yeah, so you can take over the root control of CNS. You can experiment. You can give whatever names you want to anything. You can play with it in ways that you couldn't as part of the global state. So if you're using it for development and testing purposes, you do get these extra degrees of flexibility. But that's obviously just local to you. Yeah, so that there's no use buying a name in your own local setup if other people aren't going to be able to see it and resolve it. So primarily for development and testing purposes, I'd say, when it comes to local usage of names. Okay, so let me just check the Discord. Some other questions we got asked. I like this one. Can it be used as a web address? So that's sort of interesting. So web addresses go via DNS, the domain name system, but you can have dynamic DNS names, and you could have a sort of a mapping that mapped from some DNS domain onto the Convex name system. Yeah, so I can see potentially we have something like um, let's say if we have a use a convex.world domain name, for example, we could do cns name.convex.world and have that perform a dynamic lookup into CNS. So it is possible to integrate them in that way and potentially use them on the web. Um, Question about what you want it to show if someone looks up a CNS name on the web. What do you want to see? Do you want to see the CNS record? Well, that's going to be a bit low level detail. Yeah. Do you want it to like have some kind of hypertext link and take you to whatever web page you want? You could do that. You could put that in the metadata on the CNS record and have some like web server do a redirect for you. There's lots of different potential things you might want to do. So yes, you could definitely link it to the web. There's a number of different possible mechanisms, and it might be quite interesting to explore which of those are sort of handy or useful. You could even point it to something like a web wallet or some kind of online app or something like that. So I could see it being useful. I see it possibly being useful, particularly for web apps or dApps that want to have their own name system. They'll probably want to provide a web version of their own names. Yeah. So if I have something like app dot Mike's app dot user user something, yeah, that's the kind of name that I can see people might want to provide a web version of that. Yeah, and the web version of that might be something like https uh, mikesapp.com/user 32453, and that could take you like to the user profile page or something like that. And what that would be doing is that would just be using CNS to look up that user's on-chain data within the dApp or within the web app. So it would be using CNS, but it would be providing an HTTPS sort of portal into that that sort of stage. Another question. Would Convex be blocking certain names like IBM.cvx? So open question. So if it was something that we were controlling and allocating on the basis of like humans reviewing something, then we'd probably have to use a judgment call about whether or not it's appropriate to let someone have a certain name if they were clearly trying to domain squat or something like that. Then you probably wouldn't want to do that. If it's something like an auction, I mean, could the own? I mean, I'd say probably it's up to between the person who buys the name and the person who claims the copyright to work out what they want to pay for the name or not. I mean, probably we wouldn't be. Certainly, it's not in the philosophy to be censoring on behalf of third parties. If someone on an open registration domain happened to register a particular name and IBM wanted that name, they'd have to negotiate with whoever bought it. So yeah, now that person might have trouble if they wanted to use that name without IBM's permission publicly. But they'd still be the owner of the CNS record related to it, and probably beyond our control at that point because it's a decentralized asset, and we wouldn't be able to fake someone's signature, so we wouldn't be able to um, take an asset away from someone if they've bought it or acquired it through a legitimate route. So yeah, interesting question, and I think the world of copyright and is not really evolved to be able to handle decentralized systems very well. if companies want to reserve their name, they probably ought to, get in there and reserve them early, because good names, as always, will probably go. On the other hand, namespaces are so big. There's a lot of good names. It's not like we're going to be, short of names anytime soon. So, I think it probably will be at least relatively open for people who want to find a good name early on. Okay, other questions. Um, will two-letter initials be available? Yes, no reason why not. Again, that will be part of the policy of the domain, whether they allow certain lengths. So currently I can do CNS create user.ma, and that works. Yeah, so you can have you can even have one letter. You can even have one letter user.m. That's mine. Um, you yes, you can even have a one letter names. Now, if you are issuing them through an auction, you might say, okay, 3 is the minimum. Yeah. If you're issuing them manually, and through some governance process, you might have some rules about that you want to enforce about what criteria people have to meet in order to get a two-letter domain. I mean, there's things like country codes. Yeah. So, I mean, I quite like the convention that we have currency.usd for national currencies or national equivalent currencies. Yeah. So if a nation state issues a stable coin, then you can have recognized currency codes as the names within a certain subdomain. So I think that's quite a good system. So where there are well-known international standards, we just follow them, yeah, and as makes sense for a particular part of the namespace. And again, this is the power of the flexible hierarchical namespace. You can really have completely different rules and completely different naming schemes within different parts of um, uh, the space. And I can also see us having I can see us having like an yeah, open CNS namespace where literally you can have whatever name you want, first come, first served. Yeah, and uh, that's also a possibility. So have a very liberal one. Now, obviously, if you see if you have to think about, well, is this dangerous to users? Yeah, if anyone can access a name, if you've got this complete openness, are people going to risk following, dangerous links? So there is probably some interesting challenges around governance and user education. Yeah, which links look safe, or which links should they be wary of? And I think the default answer should be you don't trust any name. Yeah, you unless you've done your due diligence and you know what rules relate to a particular namespace, and unless you know what you're risking, um, you probably shouldn't be interacting with anyone's name. Yeah, because it is a decentralized system. There will be people doing dodgy stuff. What we will do is we will have the convex namespace, which will be reserved for things that are related to shared convex infrastructure. Yeah, so this is stuff like the asset library, some of the library code, like some of the standardized smart contracts, like the fungibles, convex.fungible. Yeah, so we'll use that to give for more for developers to have the trust that, okay, any library in the convex namespace is governed by the Convex Foundation, for convenience and security. Yeah. So, but others may be like, if you have app.foo.xxx, yeah, you should be aware that that .xxx is controlled by whoever the company that runs the foo app is. Yeah, so you've got to be confident you trust those people before you trust any sort of domains that they happen to name. Now obviously the question of trust is super important. There is not much a random account can do to you harmful in Convex unless you let it. Yeah. So the following is going to be completely safe. If I do call app dot, so let's say I do CNS resolve. So I'm going to resolve the name to get an address, and then I'm going to do some untrusted function code, untrusted code, whatever parameters you want. So what is the worst that can happen to me if I do that? Right? And the answer is nothing too bad. Yeah, if it's a completely new thing, I'm not authorized anything else. I've just, all I'm doing is I'm passing control to this app.foo.xxx, but I'm doing it within a call, and the call is changing the security context to their account. So they now can't access my assets. They can't do anything on my behalf that I haven't already pre-authorized them to do. So the worst that can happen is they burn some juice and waste some transaction costs for me. It's actually pretty safe because there's a security model. Now, on the other hand, if I were to import some code from that address and run it, that could be very dangerous. I'll be running untrusted code in my own account. So you need to know what is safe and what is not safe. But the default security protections for calling a smart contract are pretty strong, and is normally the worst that can happen is you lose some transaction costs. Another question from chat: how will Convex thwart bots from gathering and squatting millions of names? So there should be a cost of acquiring a name. So you have to get the economics right. If there's an auction, for example, what's the minimum price? Yeah. And how do they have to pay a renewal fee, etc., etc., which would deter bots from just going millions and millions and millions. They might go for some high value ones, but presumably people would be competing for them anyway, so they'd be sensibly auctioned. There's nothing really, if we create something like an open namespace and let people register whatever they want, there's nothing to stop bots from going and taking millions of names. But that's part of the rules of the open namespace. Yeah, the whole point is it's open, and if people want to use bots and squat them and waste money on transaction fees gathering millions of names, they can. Yeah. Now, presumably those names would be, less valuable than ones that would be, generally more trusted. Is it a good idea for us to do that in the name of openness? I mean, maybe. But they probably wouldn't be valuable names, so I wouldn't see it being worth an attacker trying to squat millions of them. I mean, it would get expensive if you try and allocate millions. So we do need to get the incentives right. It is a good question, but yeah, there will be. I think for the well-governed ones, there will be sufficient barriers that bots wouldn't be able to exploit the access. For the open ones, it's more tricky, but then hopefully the value of squatting a millions of names on the open namespaces isn't particularly high. I mean, you can always remember someone can always create an app, app.bot, and then allocate billions of names from there. Yeah, within their own namespace. Once they've found a way to get, once you've got one CNS name, you can create infinite numbers of CNS names underneath it. Yeah. So I don't think it's a problem that as long as we control the trusted namespace as well, I don't think bots are going to be too much of a problem. But the open ones, yeah, who knows? A few more. Chat to ask a few more questions. How does someone claim a top level domain on Convex? So we would probably, this is probably something we'd want to do with decentralized governance. So I think we would want to have some kind of governance committee, you know neutral, impartial, saying how do we want to allocate top level domains, and then coming to decisions on TLDs being issued. I think it should be a slow and cautious process, because the top level ones are a sort of scarce resource. So we'll probably only start with a few, and then if the need becomes clear, then we'll have some community governance, or that will judge whether it's appropriate to issue new names. I think the basic rule is to be cautious at the start, because you can always add more, but it's hard to put it back in the box once you've released it. So we'd probably err on the side of caution with TLDs early on, and then go to decentralized governance for the future. Okay. Any other questions on these? Auction process, yes. Auction process is definitely on the table. Could be automated, fully automated auction with smart contracts, or you could have an auction process, more traditional auction process with real world stuff, and then have some governance around how those get issued to the auction winners. So that might depend a bit on which particular subdomain we're talking about, how that would get allocated. How is CNS different to ENS and unstoppable domains? I mean, I think unstoppable domains, I think, is more of a sort of separate service. ENS is quite similar to CNS. Obviously, CNS is much faster, much cheaper, etc., etc., and I think more flexible. So the flexibility that you get on Convex is very powerful. But conceptually, at least, they're naming systems that can be used to give names to entities within the system. I think one of the things that we've done with CNS that is really quite distinctive is really pushed the thinking around what a name can refer to. Yeah, so a name in Convex can refer to almost anything, because of the idea of scopes and scoped actors. So you can just point to an address. Yeah, I can just point to address like 1, 2, 3, 4. Yeah, and that's totally fine. That's kind of like pointing to a wallet address or an account address or something like that. But I can also have a scoped address, and we put that in sort of a vector. So it's 1, 2, 3, 4 is the name of the actor, which is the account which is holding this logic. But then you can have whatever you want after that, yeah, as a scope. Now that scope can be an identifier for a smart contract. It can be an identifier of a subdomain or a sub-account. It can be some code even that gets executed to do something dynamic when this thing gets operated on. It can be pretty much literally anything. Yeah. So this ability to put whatever arbitrary data you want inside the scope when you're referring to an entity in Convex means that you've got this incredible flexibility in the things that you can name, and the power of that to do quite dynamic things in terms of execution. And we've designed it so that this all works with the name system. So things like smart contracts that are not often, for example, often you want one actor, one set of code managing tens or hundreds of thousands of smart contracts. Yeah, but in the Convex Name System, you can refer to each of those contracts individually, even though it's all the same actor. So it's all actually technically managed under the same account on Convex. So that's an example of the kind of sort of extensions that the CNS has, which gives it a lot of extra power. Okay. I think that's most of the questions, and we're just sort of coming to the end. But as always, if people find this interesting, if you want to get involved in the design decisions about how we allocate these names, or find out more about how the actual implementation works, how we make it do all of this stuff, then do of course drop by the Discord. There's always people around and happy to chat about how these things work. And as always, we'll be doing a stream pretty much every week and talking about some interesting aspects right up until ProtoNet launch in the first quarter of next year, which is going to be a very exciting time. So thank you very much for everyone who's come along. Thanks for all of the great questions, whether it was on the chat or on the Discord, and look forward to seeing you all again soon. Take care.